Hello, I welcome you all to this wonderful lesson. We are starting this important topic called percentage yield. So this is chemistry. Maybe there are people that may not know this. So this is what? This is chemistry percentage yield. So the questions that I gave you, we are going to go through them in our next lesson. For now, I just want us to concentrate on this. The first thing you need to ask yourself is the definition for percentage yield. What is the definition? What is the percentage yield? Percentage yield, you need to understand that is the ratio. This is the what? This is the ratio. So we just say that it is the ratio of the what? Ratio of the actual. Ratio of the what? Actual yield. We say ratio of the actual yield to the what? To the theoretical. So we say to the theoretical from the word theory. So the one that we get to calculate from the theoretical yield multiplied by, so we say multiplied by what? Multiplied by 100%. So when we are talking about the percentage yield, from the word percentage yield, so this is a percentage. So the definition for percentage yield, we just say that it is the ratio. So ratio of the actual yield. So in other words, the formula we get to use, the percentage yield is equal to, we say that actual, we get the actual, we say actual yield like this over to the theoretical, over what? Over theoretical. So we say over what? Over theoretical yield. That's a theoretical yield. Then everything you get to multiply by what? 100%. So this is a particular formula that we need to understand. This is an important formula that I want you to know. So maybe if you get to find questions in an exam, maybe you are saying to yourself, why are you mentioning yield? What is this same yield? So you need to understand that that thing that I'm mentioning as yield, maybe you've got a question, what is a yield? Because you are saying that percentage yield, actual yield, theoretical yield, what is this same thing called yield? So this is just the amount of product produced when a substance reacts. Have you seen? So we are saying that this is just the what? Is just the amount. So I'm saying that a yield is just the amount of what? Amount of product produced. Amount of product produced when substances reacts. So amount of product produced when substances react. When what? When substances react. So I'm saying that when what? When substances do what? When substances react. So that product that is produced when two substances or when two or more substances get to react, that thing that is produced is what we are calling a yield. So a yield is just the amount of product produced when substances react. This is what you are supposed to know. And I've mentioned two things here, even as we dive into the questions, even as we get to answer these questions, I want you to know everything here. So there is now this thing on top, what we are calling the actual. We are calling it what? We are calling it the actual yield. So what is the actual yield? So we need to understand what the actual yield is. So the alternative name, the actual yield, can also be called what? This one, we can also call it as a experimental yield. So we can call it what? Experimental yield. This one is given mostly. So it is just the experimental yield. So this same experimental yield, what is it? What is this? We can call it actual yield, or we can call it experimental yield. So we need to understand what this thing is all about. So the actual yield, we are just talking about what this is. So I'm saying this is the amount. So we are saying that this is the amount of what? Amount of products. So this is the amount of product obtained. The amount of product obtained at the what? At the end. The amount of product obtained at the end of the reaction. At the end of the reaction. At the end of the what? At the end of the reaction. So this is what you need to know. So the amount of product that is obtained at the end of the reaction is what I'm calling what? Actual yield or experimental yield. Then there is also what we get to call as a theoretical yield. Have you seen a theoretical yield? Something theoretical. So when I say theoretical, what I get to mean is that this is the maximum amount of product calculated from the measured amount given. Have you seen? So when we go to theoretical, this is the calculated. So you discover that the actual one is more like given. This one is given. But when we go to this one called theoretical, so when I say theoretical, we are calling it what? We are calling it theoretical yield. So for you to understand this very well, let me also give you this one. We can also call it the expected yield. So we can also call it what? We can call it expected yield. We can also call it the expected, the one that we get to expect. So the expected, have you seen? This is the what? This is the expected yield. So what I'm telling you that this is the maximum amount of product. So I'm saying this is the amount. So this one, we are saying that this is the what? This is the maximum. I'll say this is the maximum amount of product. So amount of what? Product that is calculated. This one, amount of product calculated from the what? From the measured. So say from the measured, these ones we are getting them from the what? From the measured amounts. From the measured amounts. So this word here, it's amounts of a given reactant. Of a what? Of a given reactant. Of a given reactant using what we've used to balance. So we are saying that using the balanced equation. Using the what? We are using the balanced. So we say using the balanced equation. We get to use the balanced equation, and the more ratio, or we say the more concept. So I guess I've given you everything that you need. Actual yield. So from the word theoretical, this is the maximum amount of product calculated, meaning you have to calculate this one. You need to know how to go about this. So the actual yield is always, or I would say usually, less than the theoretical due to the way it is. Since this is a percentage, so you need to understand that the actual should always be less than the theoretical yield, so that even as we are calculating equations will form up so easily. So these are certain things that you are supposed to know and understand. You can't tell me that, okay, the actual is 6. Have you seen the actual is 6? Then the theoretical is 2. How can you find the percentage? Then you say multiply by 100. How can you find a percentage like this? So you need to understand that the actual should always be less than the theoretical. If there are no mistakes, it should just be like that. So I want you to understand it just like that. Not people get to form something like this. So whenever you just calculate the theoretical, it is 2 than the one that is given. Just know that you've made a mistake. So just know that, okay, there is a certain part which I've not calculated very well. So the reason why the actual yield is less than the theoretical. One, you discover that the reactants may fail to react completely due to the presence of impurities in them. This can also be a contributing factor to why the actual yield is less than what. So you know that chemistry is also a subject that is a bit involving. They may ask you to say, you can even find questions to say why. They may ask you to say, why is actual yield? So you can find a question like this. Why is actual yield less than the what? Less than the theoretical. Less than the theoretical yield. You can find such a question in an exam. The question is why? Why is it that the actual yield is less than the theoretical yield? One of the reasons that I've given you is that the reactants, so I'll say reactants. So this is a reason. Reactants may fail. So reactants may do what? Reactants may fail to react completely. May fail to react completely. So they may fail to react what? Completely due to the presence of impurities. Due to presence of what? Impurities. Due to presence of impurities. So this is also something that you are supposed to get. Don't say, no, so that we can find the percentage very well. That one you should just know it, but that is not, it cannot be the reason. So we've got a lot of reasons. You discover that there may be some evaporation of both reactants and products for the reaction involving volatile chemicals. So the reason why it is like that, maybe you can find that there may be some evaporation. So evaporation of, I would say, evaporation of both reactants and products. Evaporation of both reactants and what? Products. Reactants and products. So this one you have to specify. The reason why evaporation is occurring, it is because of the reaction. I will say for the what? I will say for the reaction. Not every reaction, but for the reaction involving. So I'll say for the reaction involving what? So for the reaction that gets to involve volatile what? Chemicals that get to be so stubborn. So these two are enough for you to know, but there are quite a lot of these things. So if even as we get to I guess you know how we study, like the way I'm giving you this. So when you're studying, you get your phone, you are writing these notes, so you try to analyze this clearly. You try to check and have a deeper understanding, you type on the internet, why is actual yield less than the theoretical yield? You're going to discover that you are even going to find better answers than these ones that I'm giving you, like well explained answers. You even have a deeper understanding on these things. So this is how we get to study. Whenever I'm explaining something like I've given you 2 points here, you try to find out other points that can contribute to the reason why actual yield is less than the theoretical. So you search on the internet. Okay, let me search so that I get to have more information on these things. These are simple things which I know some of you are able to answer questions, but some of you are not able. These are some questions that you get to find even in an exam. Percentage yield. People get to be confused. So I want you to know these things. I want you to know how to go about them. Let us now look at an example. So let us look at this particular example. I guess you are writing down notes. So this is an example that we are given. The question is saying, consider the reaction below. This is a reaction that we are given. Then the question is saying, when 36.8 grams of benzene reacts with an excess of chlorine, the actual yield of chlorobenzene is 38.8 grams. Find the percentage yield of chlorobenzene. So here you write the formula. Percentage yield is equal to actual. You know that this is a particular formula. So actual. This is a particular formula you are supposed to use. Actual yield over what? Over theoretical. Theoretical means the one that you are going to calculate. Theoretical what? Theoretical yield times 100%. So what we are going to do here, we need to find the what? We say percentage yield is equal to actual. What is the actual? Actual is given. This is the actual. The actual will always be given. So the actual will always be what? Given. That one will be given. It is 38.8. So 38.8 grams over the theoretical. How can we now calculate the theoretical? So we want to find the chlorobenzene. Chlorobenzene, it is this one. Want to find the theoretical yield for that one. We are given benzene, which is here. So the relationship is just between these two. And the kind of a calculation that is going to be put into consideration is what we get to call mass to mass calculation. Mass to mass what? Mass to mass calculation. I guess you remember this. So we get to use mass to mass calculation where we are given the 6.8 of benzene. So I say, okay, what I'm going to do, I get that one. I find the mass. So that is what? C6H6. I find the mass. What is the mass there? That one, what I'm going to do, 6 multiplied by 1 is equal to 6. This is 6 multiplied by 12. What answer am I getting? So 6 multiplied by 12, I do this. This is 2, remainder 1, I do that. This is 1 plus 2, 72. Like this. So when I add, I'm getting 78. There is no number there. If there was a number, I would have multiplied. So that is when I add, I'm getting 78. So that is benzene, 78 grams. To what? Chlorobenzene, this one that is given. I also do the same. So I'm just doing these things so that I know how to go about them. So that is C6H5. Why am I using chlorobenzene? First thing is because that is what I'm told to find. Then the reason why I'm using benzene, this one that is there, because it is the one that I'm going to use so that it helps me to find the mass of this one. So this is what am I going to do here. So I guess I want people to be following me. So this is 1 multiplied by 35.5. You get the answer right there. This is 5. So 5 multiplied by 1. What is the answer? So help me add everything. This is 6 multiplied by 12. Here you get 72. Here you get 5. Here you are going to get 35.5. So when you add everything, what answer are you going to get? So you are going to get 5 point. So 10, 2 remainder 1. Here you are going to have 10 plus 1, 11. So we are going to have 112. So I say 112.5 grams. Of what? Of this one, which is chlorobenzene, which is like this. So I now calculate the what? I calculate the mass. The mass that I'm going to calculate is what I'm calling the theoretical. It is the one that I'm calling the theoretical. So this one is given in the question. 36.8 grams. To what? X. I'm calculating for this one. So this cancelled. X times 78. I'm going to get 78x, which is equal to 36.8 multiplied by 112.5. So don't forget what you are doing. You want x. You divide both sides by 78. Even there, you divide by 78. This and that will be cancelled. So x is equal to, add what is on top. Here we are doing cross multiplication. This one is going with that one. This one is also going with that one. So that we find the mass. So some questions, they'll even tell you in advance, find the mass of chlorobenzene. If you find the mass of chlorobenzene that will be produced, that is the theoretical. So what I mean is that if this one is given for this one, just know that, okay, that is the actual, and what you need to calculate is theoretical. So multiply. Once you multiply, you find the answer, you divide it by 78. What answer are you going to get there? So if I'm not mistaken, I'm getting this one. So I'm getting 53.08. Then I say grams of what? Of chlorobenzene. Have you seen for that one? So I've calculated this one. It is the one that I'm going to put on this formula now. So since I've calculated this one, so I put it there now. I've calculated for this one. I now put it there. 53.08 grams. Even there are grams multiplied by 100%. What is the answer there? What answer are you going to get? So the answer that you need to get there, if you grams cancelled and it is a ratio, no units. So this to 38.8 times 100, after seeing the answer, divide it by that, you need to get 73, if I'm not mistaken, 0.1 degrees. So that is what I'm getting. So I just conclude and say, therefore, the percentage yield. So I just say the percentage yield of chlorobenzene. Of what? Chlorobenzene. So the percentage yield of chlorobenzene, that is chlorobenzene, is what? Easy. So what is the answer? 73.1%. So this is the answer, and this is how you are supposed to calculate. Hope you've seen how I've answered this one. So you just answer these questions just like this. There is no need for you to struggle about how can I answer these questions, how can I go about this. No, this is what you are supposed to do. These are simple questions. So I just want you to know how you need to calculate this, And remember, we've done this. Don't forget what we've done. So these things are interrelated. Don't say if I give you a question here, you tell me, no, we've not covered this. Even things that you know, when you are answering a question, you need to put them into practice. So these questions, they don't come like this. The concept that we've used here, this is a concept that we've been using, or the concept that we used way back. So these things, you need to know them, understand them just like this. So I guess I've explained this, and we shall continue in our next lesson where we are going to revise through. So this is a lesson. Let me just give you one question that you are going to practice. A simple question. Try to analyze this question on your own. Test your knowledge. Are you able to answer this question? These are simple things. This is not something that is so difficult. And I want you to know that this can also be called the percentage purity. So sometimes they may tell you calculate the percentage purity. It is just one and the same. You are not supposed to be confused. So you discover that percentage purity is just the ratio of the amount of pure substance in the sample to the total amount of the sample multiplied by 100. So it is just one and the same. Percentage purity and this one. So let me write down the definition for percentage purity. By the way we get to calculate them, it is just one and the same. Just that here we are using the term purity. So for the percentage purity, you can find a question in an exam that's telling you to say define percentage purity. So what is percentage purity? So I'm telling you to say that percentage purity is the ratio. So is the what? Is the ratio. I'm saying that this is the ratio of the amount. The ratio of the amount. It is the ratio of the amount of a pure substance. The ratio of the amount of a pure substance in the sample. In the what? In the sample. In the sample to the amount. To the what? To the amount of the sample. To the amount of the sample. The amount of the what? Amount of the sample multiplied by 100%. So multiplied by 100%. But it is just one and the same. The way we get to calculate percentage yield is just one and the same. So don't be confused. When they tell you to say calculate percentage purity of this, it is just the same as what? They are just telling you about what we are calling percentage yield. You can use that way of handling that particular question. Hope you've seen how I've explained this, and just answer this simple question. So just answer this simple question and see how you are going to go about it.